Evening, all of you.
Good evening.
And today we are going to talk about capability analysis.
Good evening, sir.
Good evening. Though we have already discussed on the capability analysis, we have mastered the tool CP and CPK, right? Which are nothing but process capability indices. So let's talk in general. Capability helps us to understand our ability, ability to meet a requirement. Capability means our ability to meet a requirement. But whether we will actually meet or not, that is different. But we are capable of. We are able to meet the requirement. Isn't it? Say, for example, I can help all of you learn the Six Sigma tools and techniques. But whether that is going to happen today or not, that's next thing. But in general, we are confident that yes, the time spent will be worth. Am I correct?
Yes.
Spending 1 hour time here, yes, definitely there will be some learning. The capability is there. The same thing you need to check with your process. Whether my process is really no having the capability to meet a requirement or not. And particularly when the requirement is expressed in terms of a measurable characteristics, particularly when the requirement is expressed as a measurable characteristics. Say, for example, the what do you call the turnaround time of a process must be less than 48 hours. Within 48 hours, the entire process must be completed. Are we really capable of doing it or not? And imagine you have a process which have a tendency to no to get the process completed, let's say in 8 hours. But customer is okay to wait up to 48 hours. But what is your process tendency? It will get over in 8 hours itself. If this is the scenario, tell me, are you running a capable process? Yes or no?
Yes, yes, sir. Yes.
You are
Yes.
running a capable process because your process turnaround time is 8 hours. But customer is giving you, yes, I can wait up to 48 hours. And your capability is not very high. Your capability is very high. And tomorrow you are getting another customer. That customer says, I can wait only for 6 hours. But what is the tendency of your process? It takes up to 8 hours. But what is the customer requirement? It's only 6 hours. And now for the second customer, the same process is not capable. Can you understand?
Yes, sir. Yes.
The process is
Yes, got it.
considered, is considered capable for a specific requirement by a specific customer. Suppose if there is another customer or the same existing customer changes his requirements, then the process capability has to be checked again. Okay. So I used the word measurable characteristics. Measurable turnaround time is measurable, right? And the dimensional characteristics are measurable. And material characteristics are measurable. Strength, hardness, surface finish, thickness, length, diameter, sugar level, weight, cholesterol level, all of these things are
Measure.
measurable. You might have noticed,
Measurable.
whenever we go for a medical checkup, they always give a normal range, isn't it? Cholesterol level, normal range. Sugar level, normal range. And BP level, there is a normal range. Say, for example, sugar level, fasting blood sugar. 80 to 100 is normal. 80 to 100 is
Value,
normal.
they will give the value. Yes.
Yeah, 80 to 100 is normal. How do they understand? Based on the population data, isn't it? They have people certain age, they know the age group of the people, they have already have a wealth of data, and they found that, and for normal people, the sugar level during fasting will be 80 to 100. Anything below 80 is considered an outlier or an abnormal value. Similarly, anything above 100 is also considered abnormal value. And now, what is the process here? And the process here is, how do you maintain your sugar level? How do you maintain your sugar level? There is a process behind, yes or no? All of you have a
Yes.
daily routine which keeps
Yes.
on repeating. It keeps on repeating. Every day you sleep for a certain number of hours. Every day you have breakfast, lunch, dinner, and every day you do certain tasks.
Yes.
The certain things, you do it in this, proper, same manner. That means it's well standardized. But there are certain things which are not standardized. A particular day you might be experiencing a heavy stress, and these are all, telling that the process is, not properly standardized. So that means there are certain uncontrollable scenarios. That is the meaning, isn't it? If you have not standardized, it means you are not prepared for it. So there are some uncontrollable factors which can come and disturb your process, right? And because of these uncontrollable factors, your process, might get disturbed and might produce values beyond the normal range. Beyond the normal range. So we need to understand that. We need to understand that whenever our process is influenced by some uncontrollable factors. That is the reason why we have not, we have not prepared, we have not made a control plan. So, but those uncontrollable factors can come and affect our process occasionally. And all those times, yes, our process will produce output beyond the expected rate. There is another way our process can fail. You know what is another way our process can fail? Even sometimes we make mistake on the standardized steps. Yes or no? We all know we need to sleep for 8 hours.
Correct.
But still, one particular day, we go for a movie, second show, and that day our sleepover will be reduced to 6 hours only. This will also disturb our process, yes or no?
Yes.
So we need to
Yes.
understand there are two ways our process can get disturbed. One is uncontrollable factor can come and affect our process. Another thing is the controllable. If you miss to control, that can also affect our process, right? So we need to be, aware of these things, and that is why we should keep on monitor a process and ensure our control plan is also improved on a long term, so that in the long run you will be able to take care of both the controllable factors as well as, try to ensure the uncontrollable doesn't affect our process. Okay. So now, in order to measure the capability of the process, we have already learned a metric known as CP and CPK. They are known as process capability indices. And when we actually calculate the CP CPK, we consider the variation. We consider the variation within the scope of the study. We consider the variation within the scope of the study. What is variation within the scope of the study? How are you collecting the data? How are you collecting the data? Let's say you collected the data for 3 hours. You collected the data for 3 hours, and every half an hour once you have taken some sample, and you observed the process for a duration of how much? 3 hours. And now within that 3 hours, what are all the the factors you have been controlling. But you know what will happen? Suppose if the same process is made to operate, let's say for 30 days, do you think the same number of factors only will be affecting your process? We observed it for 3 hours, right? We know the known factors. But when I stretch the study for 30 days, there can be some unknown factors which can come and then disturb my process. Is my statement correct? What I observed within the 3 hours, yes, that is one side. But what I will observe, over a period of 30 days, that can be different. If I stretch it over 300 days, yes, that can also be different, isn't it? So the chances of some additional factors coming and influencing our process will be higher when I consider the longer term. Am I right? So your process certainly has the capability. One is according to the short-term factors. Whereas there is another set of factors which can be called as long-term factors. What is a long-term factor? If I stretch the study from 3 hours to 30 days, I now will certainly get influenced by another factor known as shift. Am I right? Because within 3 hours, it is only one single shift. But 30 hours means there can be a first shift, there can be a second shift. Am I right?
Yes.
And during the 3 hours, only one operator would have engaged in the machine. But when I stretch the study for 30 hours, now what happened? There can be multiple operators. Sometimes even raw material, batch can change. Am I right?
Yes, it's happening, sir.
Exactly. So we should also think about whether our process will be capable when these additional factors also influences. You understand? We need to check whether our process is capable within the, with respect to the factors considered within the study period. Another capability is whether our process will be capable, when some additional factors are also considered. So that there is a short-term capability, there is also a long-term capability. But what we can do is, with the help of the data available in our hand, with the help of the data available in our hand, we can get an estimate of both the short-term capability as well as the long-term capability. Do you think what I'm telling is possible? I conducted the study only for 3 hours. But within that 3 hours within the data generated during the 3 hours, I will calculate the short-term capability as well as the long-term capability. But another highlighting point here is both of them are estimated value. In statistics, nothing is an accurate value. Everything is an estimated value only. With the data available in my hand, I will get an estimate of the short-term capability. I will also get an estimate of the long-term capability. Is it clear to all of you, first of all? One side is short-term, the other side is long-term. So, and the short-term is known as CP/CPK. The long-term is known as PP and PPK. Based on the studies already conducted, statisticians have realized there is a relationship between short-term capability and the long-term capability. There is a relationship between short-term capability and long-term capability.
Long-term.
You know what will be the relationship? In terms of sigma level, right? And I hope all of you have a clarity about what is sigma level, right? What is sigma level? Imagine if the control limit, all of you, do you know control limit?
Yes.
What is the formula? Process average plus or minus 3 times standard deviation. Am I correct? Process average plus or minus 3 times standard deviation. I will write something. There is a whiteboard, new board. Okay. So let me take a pen. Yeah, pen is here. Yeah. You see here, I have drawn a process, a bell curve. And this process has got a control limit, upper control limit, and it has got a lower control limit. And what is there at the center? Average.
X bar average.
Correct. Now, the customer says, I need the values within this. Now, what happened? Where is the customer marking his limits? Exactly on the control limit. Can you see that? I have drawn in that way only. Exactly.
Yes, yes.
The specification limit is marked exactly on the control limit. And we very well know if the control limits are known, the distance between the control limit will be how much?
Six
Yeah.
standard deviation.
Yes, 6 times standard deviation. That means the right side is 3 sigma, the left side is also 3 sigma. In such a condition, the process is considered to be a 3 sigma process. In such a condition, the process is considered to be a 3 sigma process. Now, what is the definition of a 3 sigma process? The control limit and the specification limits are overlapping with each other. Clear?
Okay.
So customer is okay to wait 48 hours. And your process also takes 48 hours to complete. Now the control limits are overlapping with specification limit. Am I correct? Your monthly earning is 2 lakhs. Out of the 2 lakhs, your wife is spending all the 2 lakhs as expense on the same month. Now what happened? Again, your process is just capable, yes or no? Your process has just made it. So these scenarios, in this scenario, we call the capability as 3 sigma capability. Everything looks good, but in the long run, there can be a problem. Yes or no? If you spend all the money in the same month, everything looks good. You do not have any, shortage. Everything goes well. But tell me honestly, will it be good for you in the long term?
No.
Definitely no. Some emergency, some additional factors can definitely disturb, and we are not prepared for that. So if you want to be prepared even for the long term, what should you do? What should we have done? We should have limited our expenses, isn't it, to a value much lower than our earnings. Am I right?
Yes.
If you are earning 2 lakh, somehow if you manage to bring down your expenses to less than 1 lakh, you are even prepared for the future demands. Yes or no?
Yes.
Suddenly, the price is increasing, everything. Then also you will lead a comfortable life, right? So when your earnings are 2 lakh, but expenses are lesser than 1 lakh, you are now doubly capable. You are now doubly capable. Now your capability in terms of sigma level is 6. Can you see that? You are not running a 3 sigma process now. You are running a 6 sigma process. Your earning is 2 lakh, but expense is 1 lakh or below.
1 lakh.
Now, can somebody define what is a 3 sigma process or what is a 6 sigma process with respect to control limit and specification limit? Can you define what is a 3 sigma process based on control limit and specification limit? Will you be able to define? Come on, feel free to try.
Six Sigma process where we do a control mechanism to, I'm not sure whether I'm right or wrong. Six Sigma is a
Right.
process where we can stop the wastage. For example, our earnings is 2 lakh. We can define that we earn a 2 lakhs and we spend the 2 lakh without any savings or without any planning or control mechanism. It is a short term, long term, we can't do anything. In Six Sigma, we can define that this is the control mechanism. For example, whatever I earn 2 lakhs, within 50,000 to 1 lakh, we can spend it. Remaining 1 lakh, it should be in the savings account. There plays the main mechanism of main role plays for the Six Sigma, where it comes, it's seeing the wastage, how much I'm unnecessarily wasting the money. So that will be controlled. Check whether it is necessary to spend or not. I have to
Okay.
control range.
Okay, good thinking. Good thinking. Let me explain. Now see here, there is a lower spec, there is an upper spec. For any given
Yes.
month, you can spend anywhere between 0 lakh to 2 lakh. Right? You can spend anywhere between 0 lakh to 2 lakh. That means, okay. But that means the 0 to 2 lakh represents what? It represents your salary. Am I right?
Six Sigma.
Yes.
It represents your salary. And this you are responsible for. Earning is your responsibility, and you are very clear, 0 to 2 lakhs. And who is spending? Your wife is spending, right? Your wife is responsible for spending, and now she can decide to operate here. Yes or no?
Yes.
She can decide to operate here.
Yes.
She can decide to operate here.
Yes.
She can
Yes.
decide to operate here, and somebody can even operate like this. What does it mean? What do you think about this lady?
Well controlled.
Well planned, isn't it? Well planned, well controlled. She always ensures the spending is, somewhere, below 75,000. Yes or no?
Yes.
And moreover, please note, when we talk in terms of expenses, moving towards LSL is not a problem. It's actually a good. Am I right?
Yes.
Moving towards right is the problem. You need to understand, right? So in this case, your target is on the left side, right? So this lady is good and this lady is also okay. She is centered properly. On an average, she is spending 1 lakh. But she is so consistent, isn't it? Maximum she go up to 1.25 lakh. But this lady, yes, you could understand the risk here, isn't it? She is always on the higher side. Can you see here? It's somewhere around 1.6 or 1 point some lakhs. But this lady is definitely not suitable. Yes or no?
Beyond the
Yeah,
beyond
this is
the
definitely a process which is not capable. So what do you understand when I move from left to right, from lady 1 to lady 4? What do you understand? You can see, can you see a shift in the process? You can see a shift, isn't it? Rightwards. When our target
Like
is on the left, but my process has a tendency towards, the right side. So where if the process is shifting, you can understand the shifting of the process through these lines. You see, what is this line? X1 bar. And this line, X2 bar. And this line, X3 bar. And this line, X4 bar. What are these X1 bar, X2 bar, X3 bar, and X4 bar? X4 bar?
average.
Process average.
Process.
Whenever you collect the data, have a look at the process average. Try to check whether the average is at the preferred location or not. If the average is moving away from the preferred location, you can understand, the risk is increasing. Am I right?
But we can't call them as a median. Right?
Yeah. We see normally we call it average only. When should we go for median? When your data is non-normal. When you see right now our assumption is data is normal. If data is non-normal, yes, then we have a procedure to still, use the same concept. A non-normal data must be converted into a normal data. That we'll talk little later.
Okay,
But
okay. Yes,
the
thank you.
average will be the representative of the central tendency if the data is normally distributed. And normally we assume data is normally distributed. So what we understand here is in the long term, any process can shift. Am I right? In the long term, any process can shift. You think about your own expenses. 10 years before, what was your expense, monthly expense, and now what is your monthly expense? Can you see a shift happen? Yes or no?
Yes.
Definitely, isn't it? So always in long term, there will be a shift. any process will, experience a shift, and statistician, they have developed an empirical, formula, according to which, in terms of sigma level, there will be a shift of 1.5. There will be a shift of 1.5.
1.5.
Suppose my process is doubly capable today. In terms of sigma level, what is the sigma level? 6 sigma. Doubly capable means what? Doubly capable means control limit is here, but specification limits are here. Am I right? This is UCL, whereas this is USL. This is LCL, whereas this is LSL. What do I mean by doubly capable?
Both the sides the process is controlled.
Yes. Yeah, both sides. If I measure the distance between control limit, I very well know this will be 6 sigma for any process. This will be 6 sigma for any process. Then what will be the distance between the specification limits? It should be 12 sigma, isn't it? Are you getting me? Or otherwise, let me put some numbers. Let us say this is 20. Then this will be 40. Do you get my point? 20, 40. Let's say customer has given, 100 plus or minus 20 micron. Now 100 is at the center, 120 is at the right side, and 80 will be at the left side. Am I right? What is the distance between 80 and 120? Tell me.
40.
That is what I have written here. Now your process should operate around this 100 microns. At the same time, the control limit of your process should be around 110, and lower control limit should be 90.
90.
Now, out of the 40 microns tolerance given by the customer, how much tolerance your process is consuming? Only 20 microns, yes or no? Customer has given 40 microns, but my process consumes only how much microns? 20 microns. At the same time, it is operating at the right spot. 100 is the target, it is operating at the 100. How do I say? My process has got an average. In this scenario, the process is considered doubly capable. Am I correct? All of you are understanding?
Okay.
My process is doubly capable.
Doubly.
Statistically, this is referred as 6 sigma capability. Do you understand? Statistically, this is referred as 6 sigma capability. Is that clear?
Yes, sir.
In this
Yes.
scenario, the CPK will be 2. In this scenario, CPK will be 2. CPK 2 means it's a 6 sigma process, right? And if CPK and CP are equal, that means what? What does it mean if CPK and CP are equal? The process is on the target. See here, customer given a target of 100, and where is my process centered? That is also on the same 100, isn't it? Process average also 100 microns. Customer target is also 100 microns. That means CP, CPK are equal. Very good. So you now know, all of you know how to how to measure the capability, right? There is a 6 sigma capability. There is a 3 sigma capability. 3 sigma capability, what is the understanding? Control limit. Control limit. Control limit will overlap with specification limit. Am I right?
Yes,
Yes or
sir.
no? Yeah. Whereas if your process has a capability of 6 sigma, then your control limit will be well inside specification limit. Well inside specification limit. Or in other words, the distance between the control limit will be half the distance between the specification limit. Hope you are able to understand all these statements, isn't it? You should be able to connect all of this. Am I correct? Yes or no? Very good. And also, this is what we actually call it, CP and then the CPK. CP and then the other one is CPK. And you all know the formula. Can anybody tell me what is the formula for CP?
upper specification limit, lower specification limit divided by 6 sigma.
Very good. Upper specification limit minus lower specification limit divided by 6 sigma. This is CP. Then for CPK, you have minimum of
Upper control limit minus x bar divided by 3 sigma.
very good. Minimum of CP upper, CP lower. Now, what is
Yes.
this CP upper? CP upper, as you rightly said, this will be USL minus X bar by 3 sigma. And similarly, CP lower. Here, this will be X bar minus LSL by 3 sigma. We have this formula, all of you have already studied. Now, what I want all of you to know at this stage is how to calculate the sigma in this formula. How to calculate the sigma throughout the meaning of sigma. The meaning of sigma, I'll tell you. The meaning of sigma is, this is how you all must calculate, right? What is the formula I'm writing?
R bar divided by D2.
R bar by D2. You must memorize. You should always use this formula only. Don't use any other formula. If you use any other formula for calculating standard deviation, you may not get CP/CPK value. You may get some other value, right? So to avoid the risk, always use R bar divided by D2. If you use this formula, this sigma will now be referred as sigma within what I have written? Sigma
Sigma within.
Within.
Yeah. This is one type of standard deviation. There are two types of standard deviation you must know. When you have processed data in your hand, one type of standard deviation is within standard deviation. So we are understanding within standard deviation here. R bar divided by D2. Now what is this R bar?
Range.
This R bar is nothing but the center line in R chart. Am I right? There is a control chart. There is a control chart. In fact, when we talk about the capability analysis, we must necessarily have what? We must necessarily have control chart. And in the control chart, the famous one is X bar R chart. In the R chart, there is a center line. That center line is nothing but what? R bar. Am I right? Are you with me?
Yes, yes.
Yes.
Very good. So you must pick up that R bar. If you have some other way of calculating the same R bar, and if you are confident about it, do it. Or if you are not confident, plot the control chart, R chart. Look at the center line and try to understand the value. That is your R bar. Now I will show you how can we refer to that R bar, right? So I'm sharing my complete screen. So you can now see my screen. See this file I have already shared with all of you, sigma level calculator. I am just opening. You all know the password is GSK. So now this is opening. And now we can refer to some data. Like, yes, I'm just going to this sheet. Yeah. Coating thickness. Coating thickness. It's a simple file. See here. Now, coating thickness. See here, every 1 hour, first 1 hour, they have taken 3 samples. Next 1 hour, they have taken another 3 samples. Do you understand their sampling frequency? Hourly once. 1 hour once, they take how many sample? 3 sample.
3 samples.
Now, if I ask you what is the sample size, what is your answer now? Sample size is
3.
Hourly
3.
taking number.
Sample size is 3. Sampling frequency is hourly once.
Hourly one.
You should know all of those things, right? So now the sampling is done for about 25 hours. You can see here. Can you see here? 25 hours the study is conducted. Am I right? So now there are 2 scenarios now. One is every 1 hour we are taking a sample. Every 1 hour we are taking a sample. So the samples collected within the 1 hour. How many samples we collected within 1 hour? 3, right?
3.
These 3 samples, if you analyze, you will be able to understand the variation within that 1 hour. Am I right?
Yes.
Like today class is
Yes.
8 p.m. to 9 p.m. Within this 1 hour, you will have challenges. Am I correct? You will get a phone call.
Yes.
You will have television running on the other side, and somebody will be calling you for dinner. And these are all challenges within this 1 hour. But suppose if I have another class tomorrow also, you will have some other challenges. Am I right? Within this 1 hour also there are challenges, and between also there is a challenges. If there are no 25 classes, overall there can be some challenges. Am I right? All challenges are not same. Am I right? Yes or no?
Yes.
Managing the
Yes.
challenges within this 1 hour, 8 p.m. to 9 p.m. is very easy. That is the easiest one. This is what we call it within variation. But next to 25 days, you have to allot your time for learning. Now, this is a big challenge for you. Correct? 25 days, you have to ensure you are not occupied by some other works. You have to dedicate for the learning. Now, this is overall variation, right? And now, as far as this data is concerned, there are how many data points I have right now? 25 times sample is taken. Each time 3 sample is taken. Each time 3 sample, totally 75. I copy all of these 75 sample. You know what I'm going to do? I'm going to open Minitab now. I think all of you are familiar with the Minitab as well. Because as the Minitab opens, it will be easy for us. Let it open. Okay, let it open one side. Let us also talk on the other side. Now, this example, totally there are 75 data points. Totally there are 75 data points, and we can observe the variation within every group of 3 sample. Every 1 hour, we took 3 sample. Try to study the variation within the 3 sample taken in the first hour, and 3 sample taken in the second hour, 3 sample taken in the third hour. This way of studying the variation is within variation. Another way of studying the variation is totally how many data points you have? Tell me.
75.
75.
75. Now, one of you can study the variation in all the 75 data points. Variation in all the 75 data points. And obviously, the overall variation will be higher, right? So that overall variation will be higher. So now we need to understand how much is within variation and how much is overall variation. For a properly controlled process, the within variation and overall variation will be same. Do you understand? Some participant will be very sincere during every class and they will ensure they attend all the classes. Do you get my point? They are sincere within that 1 hour, and not only that, they attend every class every day. They attend all the classes all 25 days. But there can be a few participants who will be sincere within every class, but they may miss attending the classes regularly. Now I am pointing two category of participants. What is first category of participants? They attend all the classes sincerely, right? Every 1 hour they are completely committed, and every day also they are committed. Now for the first category, the variation within 1 hour is minimal because their attentiveness is same from the first minute till the last minute. Do you get my point? Within variation is very, very low. And they maintain this process every single day. That means the overall variation is also under good control. Am I right?
Yes.
Yes.
So for these kind of participants, you don't see any abnormality in their performance. Anytime you go and check, their performance is as expected. That means the short-term variation, which is nothing but within variation. Another one is long-term variation, also known as overall variation. But maintaining this condition is not that easy. It requires a lot of discipline. Now come on to another side. Another category of participants. Whenever they attend the session, they are very sincere. But their problem is they cannot attend all the session. If you particularly, if you check, they know all the subject, they score very high marks, they are very sincere. But the problem is what? Some days, they are not able to attend the class. For them, the within variation is, under control according to the data. But overall variation, there is a big problem. Yes or no?
Yes.
So for those kind of participant, the short-term variation is under control. If they come for attending the class, they ensure they are attentive throughout. But their problem is they are not able to control the long-term variation. They have to attend so many meetings and so many, external factors. So the same influences are possible for our process as well. Can you see my Minitab screen now, all of you?
Yeah,
Yes.
Yet to come. Now it's okay.
Now it is visible. See here, now I pasted the copied data. This is a coating thickness, right? This is a coating thickness. Look at the variation in the first 3 sample. Are you seeing the variation?
Yes.
Look at the variation in the second 3. Look at the variation in the third 3. The third 3 seem to be more in control. Can you see? Yes or no? Everything is 49. Yes or no? But if I ask you to check all 75, look all 75 data. Now I'm talking about overall variation. If you talk in terms of within variation, you are actually measuring CPCPK. If you talk in terms of overall variation, you are actually measuring PP and PPK, because the overall variation represents the long-term variation. The within variation represents short-term variation, right? So the short-term capability, if you want to understand, you must use what?
CPCPK.
Within variation. That means you will be calculating CPCPK. Suppose if you want to understand the long-term capability,
PPPPK.
And now you must use the overall variation. And very rarely, only for well-disciplined people, the within variation and overall variation will be same. It's not true for everybody, isn't it? It's not true for all process. So if you use the overall variation, you will be getting PP and PPK. Just in case, if CP-CPK is equal to PP-PPK, what do you understand? What do you understand about this kind of process? What do you understand about this kind of process? CP and CPK are equal to PP and PPK. That means, can I call it as a very healthy scenario? Right? At the same time, all of them, all of them are more than 1.67. Very, very healthy scenario. Do you understand? Your process is capable in short term as well as capable in long term. All right. Now for the given data, let us check whether what is the short term capability, what is the long term capability, right? And also let us also check how is the control chart scenario. All that we are going to check. So go to stat, go to quality tools, go to, you can in fact even consider this capability analysis 6-pack. Capability analysis 6-pack, assuming the data is normal. When I use 6-pack, I will get everything, including control chart, single column. What is that column? Thickness. Select. Now tell me, what is the subgroup size?
3.
3. You have to give 3. What is the lower spec? What is the upper spec? Customer requirement has to be declared. Customer requirement is 50 microns plus or minus 3 microns is the requirement for coating thickness. So 50 micron means 47. Right? Lower specification is 47 microns. Upper specification is 53 microns. Are you with me, all of you? The lower spec, upper spec is declared and data is given. Now Minitab is going to calculate everything for me. I'm going to say okay. Now Minitab has done the job for me. Look at the graph. Look at the details. And see, first of all, there is within on the left side. Can you notice, all of you? My cursor within. What is the CP?
Deviation CP 2.4.
2.46. What is the CPK?
2.3.
2.3.
2.37. That means, considering the within variation, the process is capable. Correct? Within
short-
variation wise, the process is capable. I have conducted a study and whenever I check, the participants seem to be in the class, seem to be very attentive and seem to, be performing very well in the exam. So whenever I check, yes, the participant is, really doing very well. But when I look at his mark over the complete semester, I see a problem. Possible, yes or no? And that is what is available here. Look at PP 1.19, PPK 1.15. Can you see the capability reducing to half the value? Yes or no? Can you
Yes,
see the
yes.
capability reducing? See, if a process loses its capability, there are two possibilities. One is the process can shift. Upward or downward. Another thing is the spread of the process can increase. Whether the spread of the process is increasing or not, you will be able to understand by reading the R chart. Can you see the R chart?
Yes.
The spread seems to be more or less under good control. You see, the R chart is completely under control. Look at the center line in the R chart. How much it is?
0.701.
0.701. And then what is the name of 0.701? R bar.
R bar.
This is what I was referring, center line in the R chart, right? So the process spread, I don't see any problem, but the process is shifting. You see here, sometimes it is shifting upward, sometimes it is shifting downward, again it is shifting upwards. Can you see the red color spots indicating the shift of the process upward and downward? Yes or no?
Yes, sir.
Yes.
So this kind of shifting can happen in the long run. So we calculate, another standard deviation. See here, there is also within standard deviation. Within standard deviation is how much?
0.406.
0.40. For calculating within standard deviation, you have to use this center line R bar and divide it by D2. D2 is a statistical constant. You all know that statistical constant depends on sample size. In our case, the sample size is 3. For a sample size of 3, the value of D2 is 1.693. You can even Google it, or you can also find it in our slides as well. So 1.693. So when I do that, I get the sigma. But when it comes to the overall standard deviation, how can you calculate overall standard deviation? Tell me totally how many data points you collected?
75.
75. Put all 75 data in a single column and calculate the standard deviation out of it using Excel or any other formula manually also. And the calculated standard deviation is found to be 0.8385. This indicates you might experience double the problem in the long run. The process might experience double the problem in the long run. Whatever you observe right now, the problems can be at least double in the long run. You can talk in terms of maybe the rejections. If there are no rejections in the short term, but still in the long term, some rejections are expected. And that is indicated in the form of PPM. Can you see here? The PPM is 0 here. But what is the PPM here? 394. None of the point within the 75 has fallen outside the specification. That is evident here in the histogram as well. You see here? In the histogram, all the points are within the spec, upper spec and lower spec. But still, I expect the same process to produce parts beyond the specification in the long run. Right? So according to that, 394. Why do I expect failure in the long run? Because my standard deviation has doubled. Can you see here, all of you? My standard deviation has doubled. If I used the same data to calculate the short-term capability as well as, to calculate the short-term variation within variation as well as the long-term variation, which is nothing but overall variation. I used the same horoscope to find out how good is your time in the present as well as how good will be the time in the future as well. Correct? We used the same information, same manner. We have used the same data. Please note, all of them are estimates. First of all, please understand, all of them are estimate. Even though I am reading from your horoscope, it is only a prediction. Still, something different, there is also a chance that something different can happen. But we try to predict as close as possible to the reality. But according to the data provided to us, our understanding is this process is certainly capable in the short term, but may lose its capability and produce rejections in the long term. Do you understand, all of you?
Yes.
The process is capable in short term, but not capable in the long term as per the guidelines, because the guidelines demands a value of how much? 1.67. That is not happening with the PP and PPK. Am I right? Are you with me, all of you?
Yes.
Anybody would like to try this by yourself, because you do have the Minitab as well as the Excel data, right? Hereafter, when you have the data, first try to understand what kind of data it is. Is it thickness? In my case, in your case, it can be surface finish. In your case, it can be exam mark. In your case, it can be sugar level, BP level, cholesterol level, or it can be height of the growth of the plant. Whatever measurable characteristic, that's all. And you should also know that you should also have the clarity. What is the acceptable range? Once the acceptable range is understood, upper spec is clear, lower spec is clear. Am I right? Upper spec is clear, lower spec is clear. And now what you need to understand is you need to understand the process. Understanding the process means what is the process average? What is the process standard deviation? For short term, refer to within standard deviation. For long term, refer to overall standard deviation. For some good process, the within standard deviation will be 0.4061 and overall standard deviation might be 0.4161. Do you get my point? If the overall standard deviation is 0.41 and within standard deviation is 0.4, what do you understand? They are close to each other. Do you get my point? If they are close to each other, that means even in the long run, your process will perform in a highly stable manner. It can it can certainly work in the same fashion even in the long run. Is this explanation helpful? All of you, please confirm.
Yes, sir.
Yes,
Yes.
sir. Yes, sir.
Yeah,
But sir,
but certain what do you call observations we need to make here. When I look at the X bar chart here, please note, many of the points are out of control, isn't it? Many of the points, red color points. So whenever the abnormalities are noted or special causes are noted, the best practice is investigate for the special cause. The company should have the habit of investigating on each and every special cause. If such procedures, such culture is not there, your conclusions based on CP/CPK can be highly misleading. Do you get my point? If you come across such a similar report, what I am showing, and if there are so many out of control points or so many special causes, when there are no explanations available, there are no investigations carried out, there are no actions taken, in such a scenario, whatever conclusion you derive from these values here, that can be highly misleading. All of you, do you understand the risk involved in the current report? All of you, do you understand the risk involved in the current report? Right? Because see, these special causes indicate, what do you call, the poor stability of the process. Right? But in spite of the poor stability, how are you getting, higher, very healthier CP/CPK value? Because customer has given you a wider tolerance, but your process is operating with a narrower spread. That is the reason. Because of that only, in spite of the special causes, still nothing is getting rejected at the customer side. But it doesn't mean that you are under good control. You are definitely under poor control. What do I understand? How do I identify that? By seeing the special causes. Yes or no? Your child is writing exam, all the exam marks are pass mark only. But you still find some problems over there. You know why? Normally your child score above 80, but this time you have seen all the exam mark below 80. All the exam marks are around 70 only. But normally where do you get? Above 80, isn't it? But both are pass mark only. Above 80 also pass. Above 70 also pass. There is no problem at all. But still, I understand the problem, isn't it? The same thing is happening here. There are special causes. But in spite of that, your process is remaining capable. Correct? Come on, tell me, all of you, you need to speak out. Otherwise, I am getting confused whether you are getting to understand with the example I am talking, you should be able to understand the purpose of within standard deviation, overall standard deviation. The purpose of calculating CP/CPK and calculating PP/PPK. Tell me, what have you understood
Yes,
the capability analysis using CP/CPK as well as PP/PPK?
Yes.
And whether it is CP/CPK or PP/PPK, it is definitely expected that your control chart demonstrates statistical control. There should not be special causes. If special causes are there and still the process is capable, and you very well know no investigation happened, no corrective action happened, and that is an indication that there is a big risk of what do you call working with such companies. Yes or no? If they really don't take any action on the special causes and no report is available, nothing is available, it is definitely a risky association. Am I correct or not?
correct. Correct.
Data shows, today they are okay. But then also culturally, I see a problem. They really don't have a knowledge about what is common cause, what is special cause, and they simply ignore all the special causes. Such kind of partners, might pull you down anytime. And you should always insist for a proper statistical control in the control chart, and then look at the CP/CPK. That is the best way you can, believe any process or any company that you audit. CP/CPK, PP/PPK must be acceptable. Control chart should also be acceptable. Then it's a healthy scenario. Control chart under super control, within variation is very, very low. Overall variation is also very, very low. And within variation and overall variation are almost same. In those scenario, CP/CPK and PP/PPK will also be same. Which means the short-term capability as well as the long-term capability are same. The long-term capability indices are known as performance indices, process performance indices. The short-term capability indices, nothing but CP and CPK, they are known as capability indices. One side is capability, other side is performance. We should maintain both. We should always have the capability to meet the requirement. And whenever we perform, we should ensure the requirement is met, right? So, for a good process, both CP/CPK as well as PP/PPK should meet the minimum requirement of 1.67. So this is what I would like to discuss with all of you, though the CP/CPK has been discussed already, and I purposely wanted to discuss it with all of you one more time so that, you will feel much more comfortable. But one another additional learning here is we can also calculate the standard deviation in two different methods, right? That you realize today. One is using R bar by D2. The other one is simply calculating the overall standard deviation. Using the R bar by D2 value will give you CP/CPK. Using the overall standard deviation will give you PP/PPK, isn't it? So any questions that you want to ask, please feel free to ask questions. I'll be happy to clarify. Otherwise, we are done for the day. And tomorrow and day after, we will be talking more about attribute data. So far, we have been talking about continuous data, isn't it?
Yes.
And tomorrow and day after, we will be talking about attribute data. And what is an attribute data? Attribute means good, bad, okay, not
Yes,
okay,
sir.
accepted, rejected. These kind of data are known as attribute data. And for
Qualitative data.
attribute data, how to perform MSA. For attribute data, how to plot control chart. So this will be our understanding, and we will focus more on understanding the attribute data, because for the continuous data we have already done enough. So any questions on the capability analysis or the performance indices? Feel free to ask. Or if you are dealing any data, you have any challenges, feel free to discuss now. I will help you. All good?
Sir, I have one doubt, sir.
Yeah, please.
What is the difference between sample size and subgroup size?
Same. They are same. Sample size and subgroup size are same.
So both are same only.
Yeah, hereafter,
And-
whenever you read sample size, please understand they are actually talking about subgroup size. A subgroup is nothing but number of samples taken simultaneously during the sample collection. During the sample collection, if you take 5 samples simultaneously, then your sample size is 5, your subgroup size is also 5. In my example, subgroup size is 3, number of subgroup is 25.
Subgroup 25.
Yeah, 25 times I have taken sample. Every 1 hour I said, right? Every 1 hour, 25 hours, I took the sample. For me, number of subgroup is 25. Subgroup size is 3. This 3 is also known as sample size. Correct? Okay?
Okay.
Sample size and subgroup size are same. Okay, any other question?
And standard required subgroup is 25, sir. But your last class stated below 8 means X bar R chart and above 8 means X bar and S chart. You confirmed this
Correct, sir.
criteria.
Control chart, yes, we should go for X bar R chart and then X bar S chart, depending on the subgroup size. In this case, our subgroup size is 3. So
Yes.
that is why in the 6-pack, automatically the X bar R chart has come, isn't it? Okay. Nagesh, how about you? You have understood today's class?
Yes, sir.
And mostly this CPCPK and PPPPK is used in manufacturing industries. Mostly used. The automotive industry is mostly used. So for them, it will be very relevant, and they have been used to it regularly. So they could easily correlate or connect. But those who are not into manufacturing but into other domains, please take the wisdom from here. What I explained.
Sure,
The
sir.
data type must be measurable. Can a doctor conduct CPCPK study for a patient? Tell me.
On a
Sugar
medicine
level.
study, they can use, no, sir?
Yeah, medicine study. A diabetic patient ensure his sugar level doesn't drop beyond a particular value and doesn't rise beyond certain value on the higher side. Yes or no? Above also problem, and below a certain level
Below
also
also
low sugar.
problem.
Low sugar is also a problem. High sugar is also a problem. Am I correct? Can you see
Yes.
an upper spec and lower spec? Yes. And now the actual reading of sugar level from the patient can indicate the histogram, can let you understand the control limit, and you can judge whether the sugar levels are under proper control, whether his current lifestyle is acceptable or not. His current lifestyle will be considered acceptable if the control limit is seen inside the specification limit. If that is not seen, if majority of the points are falling outside the specification limit, then doctor might advise a change in the daily routine, diet, sleeping pattern, exercising. Everything, doctor might tend to change. Otherwise, you know the consequence, right? The sugar levels will be on the higher side, and it might stabilize on the higher side. If it stabilizes on the higher side, then you may have to depend on medicine, and then you may have to, might be having some complications. So to avoid that, yes, we need to correct the process. So CPCPK study can be applied to any industry, any industry. I can perform a CPCPK study with all your marks, right? And you can, suppose if you are an accounts manager, the payment time, bill processing time, they're all measurable data, isn't it? Are you running a capable process or not? And all that you can really understand with the help of what? Your data. Okay. If there are no questions, we can close here.
Sure, sir. Tomorrow,
Thanks.
next
3
2
p.m.
weeks, 3 p.m. to
Yeah.
correct.
Yeah, 3 p.m. to 6 p.m. this weekend, Saturday, Sunday, as well as next weekend, Saturday, Sunday.
Got it, sir.
Okay. Thank you. Bye bye, all of you. See you tomorrow.
Thanks for your time, sir.
Thank
Thank you so much.
Thank you. Thank you, sir.
Thank you, sir. Thank you, sir.